Now here the question, we are given this function which is defined as fx plus y, and this is fx plus fy minus xy minus 1 for all xy, and we are also given that f1 is 1. We need to find number of solutions of fn equals n. Now what we'll do is we'll find f0, and for that we'll write x as 0 and y as 0. So it'll be this f0, it'll be 2 times f0 minus 0 minus 1. So value of f0, it is also 1. Now what we'll do is we'll put y as 1. So we'll get this fx plus 1 will be equal to fx plus f1 minus x minus 1, or we can write fx plus 1 minus fx. It will be, now f1 is 1, so it will be simply minus x. Now we are looking for number of solutions of fn when n is a natural number. So we can simply write fn minus 1 will be minus n minus 1. In the same way, fn minus 1 minus fn minus 2 will be minus n minus 2. And we'll continue. In the end, we'll have f2 minus f1, and that'll be minus 1. Now if we add them, all these terms, they'll cancel. We'll get fn minus f1, and f1 is 1. It'll be this minus 1 plus 2 plus 3 up to n minus 1. So this fn will be 1 minus, and this is sum of first n minus 1 natural numbers. So it'll be 1 minus n minus 1 into n by 2. Now we need to find number of solutions of fn equals n. So we need to find number of solutions of fn equals n. So it'll be this 1 minus n minus 1 n by 2 equals n, or 1 minus n equals n minus 1 into n by 2. Now n minus 1 will cancel, so one of the solution will be n equals 1, and then the other one will be n equals minus 2, which is not acceptable. So this equation has only one solution, and that'll be n equals 1. Now here we have some questions. So starting with A, we are given that a function fx is defined on real numbers which has this property f of fx into 1 plus fx, this is equal to minus fx for all x in the domain of f. If the number 3 is in the domain and range of f, compute the value of f3. Now in this, what I see is fx everywhere. So I'll take fx as x. So we'll substitute fx with x. We can write fx into 1 plus x will be minus x, or simply fx will be minus x upon 1 plus x. Now we need to find the value of f3. So f3 in this case will be minus 3 by 4. So answer to this first one is value of f3 is minus 3 by 4. Now the second one is, suppose f is the real function satisfying f x plus fx, and it is 4 times fx, and we are given that f1 is 4. We need to find the value of f21. Now since we are not given anything else but f1, so what we'll do is we'll try and use this information. So we'll put x as 1. So it'll be this f1 plus f1, and this is 4 times f1. Now f1 is 4, so it'll be this f5, and this is 16. Now along with f1, we also have f5. So what we'll do is we'll try and put x as 5. Now if we put x as 5, we'll get this as 5 plus F5 and it'll be 4 into F5. Now F5 is 16. So it'll be 5 plus 16, which is F21. And that is what we need. And it'll be equal to 4 into F5, which is 16. And that is going to be 64. So answer to the second one is value of F21 is 64. Now this third question is, we are given a function which is defined from R positive to R positive, and we are given fxy square, it is equal to x into fy square for all positive numbers x and y, and we are given that f2 is equal to 6. We need to find the value of f50. Now we can write this as f, and 50 is simply 25 into 2. So we can write f 25 into 2 whole square, it'll be this 25 into f2 square. Now f2 square is 6. So it'll be this 25 into 6 square, or we can say f50, it'll be plus or minus 30. Now since the codomain is R positive, it can only take positive values. So the value of f50 will be simply 30. So answer to this third question is value of f50 is 30. Now in question number D, we are given a function fx with two properties. So it says for any two real x and y, fx plus y, it is x plus fy, and we are also given f0 equals to, we need to find the value of f100. Now this, what we'll simply do is, we'll put y as 0, we'll get fx equals x plus f0, and f0 is 2. So your function fx will be x plus 2, and f100 will be 100 plus 2, and that'll be 102. So answer to this fourth question is f100, it is equal to 102. Now we'll come to this last question, where it says fx is a function such that f3 is 1 and f3x equals x plus f3 into x minus 1. And we need to find the value of f300. So we can write this as f3x minus f3x minus 1. This is equal to x. Now there are two ways to solve it. Either we can solve it directly because we are required to find the value of f300, or we can say let gx equals f3x. So we can write gx minus g x minus 1. This is equal to x. Now we can write gx minus 1, gx minus 2, it'll be x minus 1. I'll continue. And in the end, we'll have g2 minus g1. It'll be equal to 2. Now, if we add them, all these terms, they'll cancel. We'll get this as gx minus g1. And g1 is f3, and f3 is 1. And this is 2 plus 3 up to x. We'll take this one on the right hand side. We can write this gx as 1 plus 2 up to x, which is sum of first x natural numbers. So it'll be this x plus 1 by 2. And here we are doing all this analysis for x belongs to n because we need f300. So here x is taken as a positive integer. So from here we can say f3x, it is x into x plus 1 by 2. Now if we put x as 100, we'll get f 300 and it'll be 100 into 101 by 2, which is 5050. So answer to this question is 5050. Now here the question is, in a function, we are given that 2fx plus xf 1 by x minus 2f, and then we have mod root 2 sine pi into x plus 1 by 4, and this is equal to 4 cos square pi x by 2 plus x cos pi by x. Now first thing is, it says prove that f2 plus f1 by 2 is 1. So for the first part, we need to find the value of f2 plus f1 by 2. Now for this, what we'll do is we'll first find the value of f1, which should be simple. So we'll put x as 1, we'll get 2f1 plus f1 minus 2f, and here will be sine pi plus pi by 4. So it will be 1 by root 2. So this also will be f1. Now this is 4 cos square pi by 2. Cos 90 is 0. And this is 1 cos pi minus 1. So from here we can say value of f1 is minus 1. So we have the value of f1. Now we need to find the value of f2 plus f1 by 2. And for this, what we clearly see is, if we put x as 2, we'll get this as f2 plus f1 by 2. So we'll put x as 2, we'll write 2f2 plus 2f1 by 2, and this is 2f, and this is root 2 sine pi 2 plus 1 by 4, and it'll be equal to 4 cos square. Now pi x by 2, it'll be simply pi, and plus 2 cos pi by 2. Now this is 2, which we take common, and then it'll be f2 plus f1 by 2. Now here it'll be sine 2 pi plus theta, and sine 2 pi plus theta is sine theta, which is sine pi by 4. So it'll be minus 2f1, and cos pi is minus 1, but it is cos square pi, so it'll be this plus 4, and cos 90 is 0. Now we know that f1 is minus 1, so we'll get 2 times f2 plus f1 by 2 will be equal to 2, or we can say f2 plus f1 by 2, this is 1, which is what we need to prove in this first part. Now we'll come to the second part, where we need to prove f2 plus f1 equals 0. And for that, we have to find the value of f2. Since we already have one relation between f2 and f1 by 2, we'll try and find another relationship. And for this, what we'll do is we'll substitute x equals 1 by 2 in the given equation. So if we substitute x equals 1 by 2, we can simply write 2f1 by 2 plus 1 by 2 f2 minus 2f root 2, this is mod sine pi 1 by 2 plus 1 by 4, and it'll be equal to 4 cos square pi by 4 plus 1 by 2 cos 2 pi. Now this is 2f1 by 2 plus 1 by 2 f2 minus 2f, Now this is sine 90 plus theta. There'll be cos pi by 4, which is 1 by root 2. So this again will be f1. Now cos pi by 4 is 1 by root 2. So it'll be this 2. And then plus cos 2 pi is 1. It'll be this 1 by 2. Now f1 is minus 1. So this 2 and 2 will cancel. If we multiply everything with 2, we can write f1 by 2 into 4 plus f2. This is 1. So now we have two equations in f2 and f1 by 2. So we can write this first one as 4 times f2 plus 4 times f1 by 2 is equal to 4. And this is 4f1 by 2 plus f2. This is equal to 1. And if we subtract, this f1 by 2 will cancel. So we'll get 3f2 equals 3, or value of f2 is simply 1. So we have f2 and we also have f1. So this value f2 plus f1 will be 1 plus minus 1 and will be 0, which is what we need to prove in this second part. Now here we are given a question which is x square fx plus f 1 minus x, it is equal to 2x minus x to the power 4. It says find this function fx and also find its domain and a range. Now we know that if we substitute x with 1 minus x, so this 1 minus x will again be x, then it will become a problem of simultaneous equations. So what we'll do is we'll replace x with 1 minus x. So we can write 1 minus x square f 1 minus x plus now f 1 minus x will be simply fx, and then we'll have 2 1 minus x minus 1 minus x to the power 4. So it is a simultaneous equation in fx and f1 by x. So what we'll do is we'll substitute the value of f1 by x here. So it'll be this 1 minus x square, and f1 minus x will be 2x minus x to the power 4 minus x square fx plus fx, and then this is 2 1 minus x minus 1 minus x to the power 4. So from here we'll get fx, and all that remains is mere calculation. So we'll take terms of fx together. So we can write fx into, and this is 1 minus x square, 1 minus x whole square, and here will be this 2 1 minus x, 1 minus x to the power 4 minus 1 minus x whole square, 2x minus x to the power 4. Now here we'll take 1 minus x common, and this is a square minus b square, which is a plus b into a minus b. So we can write this as fx into 1 plus x minus x square and 1 minus x plus x square, and this is 1 minus x, and then 2 minus 1 minus x cube minus 1 minus x, 2x minus x to the power 4. Now here also we'll take 1 minus x common, and then we'll try and solve the square. So we can write fx into 1 plus x minus x square, 1 minus x plus x square, and it'll be this 1 minus x, and then 2 minus 1 minus x. Now this is 1 minus x whole square, which is 1 plus x square minus 2x, and we have taken this minus out, so it'll be simply plus 2x minus x to the power 4. Now this 2x and 2x will cancel. We can write this as fx into 1 plus x minus x square, 1 minus x plus x square. This is 1 minus x, and here will be this 2 minus, and this is 1 plus x square minus x to the power 4, and then minus x cube plus x to the power 5. Now we can write this as fx into 1 plus x minus x square into 1 minus x plus x square, and this is 1 minus x, and it'll be this 1 plus x minus x square plus x cube plus x to the power 4 minus x to the power 5. Now from this we can take x cube common. We can write f x into 1 plus x minus x square, 1 minus x plus x square, 1 minus x, and this is 1 plus x minus x square and plus x cube, and it will be 1 plus x minus x square. We can take this common. So it will be this fx 1 plus x minus x square, 1 minus x plus x square into 1 minus x, 1 plus x minus x square into 1 plus x cube. Now 1 plus x minus x square will cancel, and we know that a cube plus b cube is a plus b into a square plus b square minus ab. So we can write fx into 1 minus x plus x square will be equal to 1 minus x, and then it will be 1 plus x, 1 plus x square minus x. Again it will cancel. So we'll get our function fx as 1 minus x square. So the function fx is 1 minus x square. Now we need to find its domain and range. So clearly there is no restriction. So domain is x belongs to R, and for range, so if we differentiate this, f dash x is minus 2x, it will be 0. So its maximum value is when the value of x is 0 and f0 is 1. So its range will be from minus infinity to 1, where 1 is included. So domain is R, range is from minus infinity to 1, and the function is 1 minus x square. Now the question is, a function f is defined for all xy belongs to R such that f1 is 2 and f2 is 8, and we're given fx plus y minus kxy is fx plus 2y square, where k is some constant. We need to first find fx and then show that fx plus y into f1 upon x plus y is equal to k for x plus y unequal to 0. Now in this, what we'll do is we'll put x as 0, and if we put x as 0, we'll get fy equals f0 plus 2y square. Now we need to find the value of f0, and we already know we are given two conditions, f1 is 2 and f2 is 8. So if you put f1 is 2, and it'll be f0 plus 2. So from here we can say f0 is 0. We can also check if the system is consistent. So f2 is 8, and it'll be this f0 plus 8. Again we'll get f0 as 0. So basically our function fx, it is 2x square. Now first we'll find the value of k. So we'll substitute this function in this given equation. Then we can write 2x plus y whole square minus kxy will be equal to 2x square plus 2y square. So it will be this 2x square plus 2y square plus 4xy minus kxy equals 2x square plus 2y square. That means value of k is 4. So from here, we'll get the value of k as 4. So this is your first part where you need to find the function. And for the second part, we need to prove that fx plus y into f 1 upon x plus y, it is equal to k. Now, if we look at the left hand side, fx plus y will be 2 into x plus y square, and f 1 upon x plus y will be 2 into 1 upon x plus y square. Now I'll cancel. So this left hand side will be equal to 4, which is nothing but k. So it means we have proved this second one also. Now the question is, let f be a real valued function defined for all real numbers x such that for some positive constant a, this equation fx plus a equals 1 by 2 plus under root of fx minus fx square, it holds for all x. Now what we can do is, we can write fx plus a minus 1 by 2 will be equal to this under root, and we know that this is x square minus x, and we can make it a perfect square. So we'll add 1 by 4 and we'll subtract 1 by 4. So we can write 1 by 4 minus fx plus fx square, and it'll be this fx plus a minus 1 by 2, and it'll be this under root 1 by 4 minus, and this is fx minus 1 by 2 square. Now we square it, we can write fx plus a minus 1 by 2 whole square plus fx minus 1 by 2 square will be equal to 1 by 2. Now in order to prove that fx is periodic, we need to prove fx plus a equals fx. And since we have x plus a and x here, what we'll do is we'll replace x with x plus a, and then we'll try and solve this simultaneous equation. So we can write f x plus 2a minus 1 by 2 square plus f x plus a minus 1 by 2 square will be equal to, this is 1 by 4. 1 by 4. And if we subtract first from second, we can write fx plus 2a minus 1 by 2 square will be equal to fx minus 1 by 2 whole square. Now we also know this fx plus a minus 1 by 2, it is equal to some square root term, so it will be greater than or equal to 0. So fx plus a will be greater than or equal to 1 by 2, and since this is true for all x, so globally fx should be greater than or equal to 1 by 2. So if we take the square root, then we can write fx plus 2a minus 1 by 2 will be equal to fx minus 1 by 2, or simply fx plus 2a equals fx, which shows this function fx, it is a periodic function and its period is 2a. Now the question is, if for all real values of u and v, we are given 2fu cos v is equal to f u plus v plus f u minus v, prove that for all real values of x, First one is fx plus f minus x. This is 2a cos x. Now clearly we can see f plus v and f minus v. So all you need to do is we'll put u as 0 and v as x. So you can write 2f0 cos x, and will be this fx plus f minus x. So from here we can write fx plus f minus x will be 2f0 cos x, and if we consider f0 as a, we can write this as 2a cos x. So that's your first part. Now in the second part, we need to prove f pi minus x plus f minus x is 0. Now the second part, we need to choose u and v such that it becomes pi minus x and minus x. One way of doing it is you can choose u plus v as pi minus x and u minus v as minus x. If you'll add them, you'll get u as pi by 2 minus x and v as pi by 2. So we'll choose u as pi by 2 minus x and we'll take v as pi by 2. So it'll be this 2f pi by 2 cos pi by 2. Now this is f u plus v. So it'll be simply pi minus x plus f u minus v, and that'll be f minus x, and cos 90 is 0. So from here we can write f pi minus x plus f minus x will be 0, which is your second part. Now this third part is we need to prove f pi minus x plus fx, it is minus 2b sin x. Now here, rather than having minus x, we are having this as x. So if we take this as x here, so we'll get u as pi by 2 now and v as pi by 2 minus x. So for this third part, we'll take u as pi by 2 and v as pi by 2 minus x. So it'll be 2f pi by 2 cos pi by 2 minus x, and it'll be f u plus v, which is f pi minus x plus f u minus b, and there'll be your fx, which we can write f pi minus x plus fx will be 2f pi by 2 cos 90 minus x is simply sin x, and since we need to prove it, this is minus 2b sin x, so we'll take b as minus f pi by 2. So we can write f pi minus x plus fx will be minus 2b sin x. Now we need to prove fx equals a cos x minus b sin x. So we already have three equations. First equation is fx plus f minus x. It is 2a cos x. Second equation is f pi minus x plus f minus x. It is 0. And third equation is f pi minus x plus fx, and it is minus 2b sin x. Now what we'll do is we'll add first and third and we'll subtract this second. So we'll subtract second and we'll add first and third. So this is going to cancel. It'll cancel. We'll get this as 2fx and it'll be 2a cos x minus 2b sin x. So we can write fx is of the form a cos x minus b sin x, where a and b are arbitrary constants. Now here we are given a function which is f x plus ay, comma, x minus ay is axy. We need to find fxy. So in this, what we'll simply do is we'll take this as some u and we'll take this as v. So we'll get x plus ay equals u and x minus ay equals v. If we add them, we'll get x as u plus v by 2. And if we subtract them, we'll get y as u minus v upon 2a. Now we'll substitute these in this given equation. Then we can write f uv will be equal to a. Now x is u plus v by 2 and this is u minus v by 2a. Now we'll replace uv with xy. So we can write fxy will be equal to x square minus y square by 4. And that's your option B. Now the question is, let f be a real valued function such that fx plus 2f 2002 by x, it is equal to 3x. Now clearly this is reciprocal substitution. So if we replace x with 2002 by x, then 2002 by x will become 2002 by x, which is simply x. So we'll replace x with 2002 by x. So it will be this f 2002 by x plus, now this is 2fx and it will be this 3 into 2002 by x. Now it's a simultaneous equation in fx and f 2002 by x. So what we'll do is we'll multiply this second with 2. So it will be this 2 and here will be this 4 and it will be this into 2. And then we'll subtract first from it. So this 2f 2002 by x will cancel. So we'll get this as 3fx and it will be this 3 into 4004 by x minus 3x. This 3 will also cancel. So we'll get our function fx as 4004 by x minus x. Now we need to find the value of f2. So this f2 will be 4004 divided by 2. So it will be this 2002 minus 2. So f2 is simply 2000 and that's your option B. Now here we are given a function fx satisfying fxy equals fx by y, and we are given that f30 is 20 and we need to find the value of f40. Now what we know is for a product fy, we just need to find fx because we'll get y simply by substitution. Now what we'll do is we'll write this f30 as f 10 into 3 because we'll need 10 for 40 also. So it'll be this f10 by 3 and we are given that this is 20. So value of f10, it is 60. Now we can write f40 as f 10 into 4. So it will be this f10 divided by 4 and f10 is 60. So 60 by 4 is simply 15. So value of f14 is 15 and that's your option A. The question is, let fx and gx be functions which take integers as arguments. So domain is integers and we are given let fx plus y equals fx plus gy plus 8 for all integers xy, and says let fx equals x for all negative integers. And it also says G8 is 17. We need to find the value of F0. Since we need to find the value of F0 and we know the value of Fx when x is negative, we'll take x as minus 8 and y as 8 because we know G8. So we'll get this as f0, and it'll be this f minus 8 plus g8 plus 8. Now fx is x when x is negative integer. So it'll be this minus 8, g8 is 17, and then plus 8. So value of f0 is simply 17, and that's your option A. Now here the question is, consider a real valued function fx satisfying 2fxy, and this is equal to fx to the power y plus fy to the power x for all xy belongs to R. And it says f1 is equal to a, where a is unequal to 1. Then we need to prove that a minus 1 into this summation, I varies from 1 to n, fi will be equal to a n plus 1 minus a. Now since we are given the value of f1, for fx we'll simply put y as 1. We'll get this as 2fx, and then it'll be fx to the power 1, which again is fx, plus f1 to the power x. So from here we can simply write this fx is nothing but a to the power x. So your function fx is a to the power x. Now we need to prove this result. So we need to find this summation. I varies from 1 to n fi. So this is a minus 1, and then this summation I varies from 1 to n, and this is a to the power I. Now this is nothing but a GP whose first term is a, and common ratio is also a, and number of terms is n. So it will be this a minus 1, and then a to the power n minus 1 upon a minus 1. This a minus 1 will cancel. It will be this a n plus 1 minus a, which is what we need to prove in this question. Now the question is, we are given this function f x plus y plus 1. It is under root fx plus under root fy whole square, and f0 equals 1. We need to determine fn, where n is a natural number. So we are looking for our natural number relationship. And since we are already given f0, so the natural substitution looks y equals 0. We can write fx plus 1 will be equal to under root fx plus f0 is 1. So it will be this 1 whole square, and it will be this under root of fx plus 1 will be equal to under root fx plus 1, which we can write under root fx plus 1 minus under root fx. It is equal to 1. Now we can use telescopic summation since n belongs to n. So we can write under root fn minus under root fn minus 1 will be 1. Under root fn minus 1 minus under root fn minus 2 will be 1. And we'll take it till under root f1 minus under root f0 will be 1. Now if we add them, all these terms, they'll cancel. We'll get a root fn minus root f0. f0 is 1, and then it'll be 1 plus 1 plus 1 from 0 to n minus 1, which is n. So clearly this fn will be n plus 1 square. Now here the question is, a real valued function fx satisfies the functional equation fx minus y, and it is equal to fx into fy minus f a minus x into f a plus y, where a is a given constant and f0 is 1. We need to find the value of f2a minus x. Now this, if we put both x and y as 0, we'll get this as f0. It'll be this f0 square minus fa whole square. Now f0 is 1, so this is 1 and this is 1. So from here we can write fa will be simply 0. Now we need to find the value of f2a minus x. Now we'll use this. So what we'll do is we'll put x as a. So we'll get f a minus y. It'll be this fa into fy minus f0 fa plus y. Now fa is 0 and f0 is 1. So we can write fa minus y will be equal to, now fa is 0 and f0 is 1. So it will be this minus fa plus y. Now we need f2a minus x. So we'll replace y with a minus x. So it will be this f a minus x, and it will be this f, and this is 2a minus x. So from here a and a will cancel. So we'll get f 2a minus xs minus fx, and that's your option B. Now the question is, if a function f satisfies the relation fx plus y plus fx minus y equals 2fx fy and f0 is unequal to 0, then which of the following is or are true? Now first we'll find the value of f0. If we put x and y both as 0, we'll get 2f0 equals 2f0 square. So from here either f0 will be 0 or f0 is 1. But in the question it says f0 is unequal to 0. So here we'll have this result that value of f0 is 1. Now we need to find whether fx is an odd function or an even function. So for this, what we'll do is we'll simply put x as 0. We'll get fy plus f minus y will be 2f0 fy. Now f0 is 1. So from here we'll get f minus y will be equal to fy. That is, fx is an even function. So option A is correct. And if f is even, then f2 equals f minus 2. And if f2 is a, f minus 2 is also a. And f4 will be equal to f minus 4. And if f4 is b, f minus 4 will also be b. So the correct options are only A and C. Now the question is, let fx plus fy equals f x into under root of 1 minus y square plus y into under root of 1 minus x square, and fx is not a constant function, then which of the following is or are true? Now if we look at it, it clearly looks like sine inverse function, because we know sine inverse x plus sine inverse y is sine inverse x into under root 1 minus y square plus y into under root 1 minus x square. So one way is just by guessing the function fx is sine inverse x, but here we are not going to use this. We'll try and solve it some other way. So what we'll do is, first we'll find the value of f0, and for it we'll let both x and y as 0. So it'll be 2 times f0. This is equal to f0, which implies f0 is simply 0. Now first we'll find if this is an even function or an odd function. And for it, what we'll do is we'll replace y with minus x. So we'll get fx plus f minus x will be f x into under root of 1 minus x square, and then minus x into under root of 1 minus x square, which is f0. f0 is 0. So from here we can say fx plus f minus x equals to 0. That is, fx is an odd function. And we clearly know sine inverse x is an odd function. Now first we'll try and figure out f2x into under root 1 minus x square. And in this we see if we replace y with x, we'll get 2x into under root of 1 minus x square. So for this f2x into under root 1 minus x square, we'll take y as x. So it'll be fx plus fx. And it'll be this f x into under root 1 minus x square plus x into under root 1 minus x square. So we'll get 2 times fx equals f 2x into under root of 1 minus x square. And that's your option D. So one of the option is this option D. Now since we have under root 1 minus x square and 1 minus y square, we know both x and y, they'll lie between minus 1 and plus 1. So what we'll do is we'll let x as sine theta. So we can write 2f sine theta will be equal to f sine 2 theta. Now this looks like sine 3 theta. So what we'll do is in this first equation, we'll put x as sine theta and y as sine 2 theta. So we can write f sine theta plus f sine 2 theta will be f sine theta cos 2 theta plus cos theta sine 2 theta, or we can write f sine 3 theta will be equal to f sine theta plus f sine 2 theta. Now sine 3 theta is 3 sine theta minus 4 sine cube theta. And this is f sine theta, and f sine 2 theta is 2f sine theta, which is 3f sine theta, and sine theta is x. So we can write f 3x minus 4x cube will be equal to 3fx. But in the option, we are given 4x cube minus 3x, and we know that fx is an odd function. So from here, we can say f 4x cube minus 3x will be equal to minus 3fx. That means the correct option is this option A. So the correct options are A and D. Now the question is, f is defined from r positive to r positive, and it's a polynomial function satisfying this functional equation f of fx equals 6x minus fx. Then we need to find the value of f17. Now since fx is a polynomial, we'll say degree of fx, it is suppose n. Then we know that degree of f of fx will be simply n square. And because this equation stands, degree of f of fx must be equal to degree of fx. So that means this is true when n square equals n. So either n is 0 or n is 1. Now, if n is 0, it implies fx is a constant function. In that case, it'll be this c 6x minus c. We'll discard this. So our function will be a linear polynomial because degree is 1. So we'll let fx as ax plus b. Now we'll substitute it. in the given equation. So it will be this a of ax plus b plus b, and it will be 6x minus ax plus b. Now we compare the coefficients of x. We'll get a square equals 6 minus a, and we'll get ab plus b, it is minus b. So it will be this a square plus a minus 6 equals 0. That is, value of a is minus 3 or a is 2, and the value of b is 0. Now since its codomain has only positive values, we cannot take a as minus 3. So the only value of a possible here is 2. So the given function fx will be simply 2x. Now we need to find value of f17. So f17 will be simply 34, and that's your option C. Now the question is, we are given a function f defined from R to R, and it says fx plus 1 equals fx minus 5 upon fx minus 3. Then which of the following statements is or are true? Now this one, it has to be a periodic function, otherwise it will be very difficult. So let's check. So for brevity, we'll say fx is a, so it will be this a minus 5 upon a minus 3. Now fx plus 2 will be fx plus 1 minus 5 upon fx plus 1 minus 3. Now fx plus 1 is a minus 5 upon a minus 3 minus 5, and a minus 5 upon a minus 3 minus 3. So it will be a minus 5a. There will be minus 4a, and then minus 5 plus 15. So there will be minus 4a plus 10, and it will be minus 2a, and this is minus 5 plus 9. So there will be plus 4, or we can write fx plus 2 equals 2a minus 5 upon a minus 2. Now we'll find fx plus 3. So fx plus 3 will be fx plus 2 minus 5 upon fx plus 2 minus 3. Now this is 2a minus 5 upon a minus 2. So there will be 2a minus 5 upon a minus 2 minus 5. And this is 2a minus 5 upon a minus 2 minus 3. Now this is 2a minus 5a. There will be minus 3a plus 5. And here will be minus a plus 1, or 3a minus 5 upon a minus 1. And looking at the options, we know that there's a difference of 4. So it could be periodic with 4. So we'll check. Fx plus 4, there'll be fx plus 3 minus 5 upon fx plus 3 minus 3. So it'll be this 3a minus 5 upon a minus 1 minus 5. And this is 3a minus 5 upon a minus 1 minus 3. Now this is 3a minus 5a. 5 and 5 will cancel. So it'll be this minus 2a. Here 3a will cancel. It'll be this minus 2. This is a. So from here we can write fx plus 4 will be equal to fx. That is, this function fx is periodic with period t. Any two values which differ by 4 will have the same value of fx. So in that case, f2008 will be same as 2004, 2006 will be same as 2010, 2006 will be same as 2002, and 2006 will be same as 2018 because 6 plus 12 is 18. So all the 4 options are correct. Now the question is, we are given a function satisfying this identity fx plus fx minus 1 upon x. It is equal to 1 plus x, where x belongs to r minus 0 and 1. And it says gx is 2fx minus x plus 1. We need to find this function gx, and then we need to solve these 3 questions. Now, looking at this x and x minus 1 upon x, we know that this is a 3-cycle substitution. So, if we replace x with x minus 1 upon x, we know that x minus 1 upon x will change to x minus 1 upon x minus 1 upon x minus 1 upon x will be minus 1 upon x minus 1. And in this also, if we replace x with x minus 1 upon x, it will be 1 minus x minus 1 upon x minus 1. So it will be simply x. So it's a 3-cycle process. So for the first part, we'll replace x with x minus 1 by x. So we'll get f x minus 1 by x plus, now x minus 1 by x will change to minus 1 x minus 1. So it will be this f minus 1 x minus 1, and will be this 1 plus, and will be x minus 1 upon x. And in the next cycle, again we'll replace x with x minus 1 upon x. Now this x minus 1 upon x will again change to minus 1 upon x minus 1. So it will be this f minus 1 upon x minus 1, and plus, if we replace x with x minus 1 upon x in this, we'll get this as x. So it will be simply this fx, and this is 1 plus, and replacing x with x minus 1 upon x in x minus 1 upon x, we'll get minus 1 upon x minus 1. So now we have 3 equations. So what we'll do is, we'll add first and third equation, and we'll subtract this equation. So here, f 1 upon x minus 1 will cancel. F x plus 1 upon x will cancel. So we'll get this as 2fx, 1 and 1 will also cancel. We'll get this as 1 plus x minus x minus 1 upon x minus 1 upon x minus 1. So that's your function fx. So your function fx will be 1 by 2, and here x upon x is 1, which will cancel. So we'll get this as x plus 1 upon x minus 1 upon x minus 1. Now it has defined gx as 2fx minus x plus 1. So 2fx minus x plus 1 will be 1 plus 1 by x minus 1 upon x minus 1, or 1 minus 1 upon x into x minus 1. Now first question is, we need to find domain of under root gx. So we need to find domain of under root of 1 minus 1 upon x into x minus 1. So clearly it will be 1 minus 1 upon x minus 1, and it should be greater than or equal to 0. So we'll get x square minus x minus 1 upon x minus 1. It should be greater than or equal to 0. Now the roots are 1 plus minus under root 5 by 2, and then 0 and 1. So we'll put them on a number line. This is 1 minus under root 5 by 2, then 0, then 1, and then 1 plus under root 5 by 2. This is plus, minus, and plus. And we do not include denominator roots. And whereas numerator roots, they'll be included and need plus sign. So it'll be this interval. So domain of this function will be x belongs to minus infinite to 1 minus under root 5 by 2 included union, not included 0 to 1 union, 1 plus under root 5 by 2 to infinite. And that's your option B. Now, second question is we need to find a range of gx. Now, gx is 1 minus 1 upon x square minus x. Now, for range, we'll take this as the y. We can write x square minus x plus 1 upon y minus 1 equals to 0. Now, this equation should have real roots. That means its d should be greater than or equal to 0. So, 1 minus 4 y minus 1 should be greater than or equal to 0. Or y minus 5, y minus 1 should be greater than or equal to 0. Now, this is 1, 5, plus, minus, and plus. 1 is not included and 5 is included. So, range of this function is y belongs to minus infinite to 1 union 5 to infinite. So, range of this function is from minus infinite to 1, but this one, it should be not included. So, if it is not included, then option C, otherwise this option D. And finally, number of roots of the equation gx equals 1. So, this third one is number of roots of the equation gx equals 1. So, this is 1 minus 1 upon x square minus x equals 1. So, from here we'll get x as 0 and x as 1. But both 0 and 1, they are not in the domain of given function fx. So, this equation will have actually no solution. So, number of solutions of this equation is simply 0. So, answer to this last question is 0, and that's your option D. Now, here we are given a function which is defined on natural numbers to real numbers, satisfying the following condition, which is f1 is 1 by 2 and f1 plus 2f2 plus 3f3 up to nfn. It is n plus 1 fn for all n greater than or equal to 2. Then we need to solve the following questions. Now, clearly, we can find fn just by replacing n with n minus 1. So, we'll take n the series. So, it will be this f1 plus 2f2 plus 3f3. And it will be this n minus 1, fn minus 1. And here will be this n minus 1, n, fn minus 1. And if we subtract the second from first, all these terms, they'll cancel. So here on the left hand side, we'll just have n fn. And on the right hand side, we'll have n plus 1 fn minus n minus 1 fn minus 1. This n will cancel. So if we rearrange, we can write n fn will be equal to n minus 1 f n minus 1. So we can simply write fn as n minus 1 upon n f n minus 1. Now we can use iterations. So we can write fn as n minus 1. f n minus 1 will be n minus 1, n minus 2, then n minus 2, n minus 3, and will continue till f2, which will be 2 and 1. Now, all these terms, they'll cancel. So we'll get fn as 1 by 2n. Now, first question is we need to find the value of f1003. So f1003 will be 1 upon 2 into 1003, and that'll be 1 upon 2006. So value of k is 2006, and that's your option D. Second question is we need to find the value of f999. So it'll be 1 upon 2 into 999, and there'll be 1000 minus 1. So there'll be 2000 minus 2, and it is 1998. So here the value of k is 1998, and that's your option C. And then we have f1, f2, f3, f4. Now f1 is 1 upon 2 into 1. f2 is 1 upon 2 into 2. 1 upon 2 into 3. 1 upon 2 into 4. Now we can write 2n as 1 upon fn, and we know that sequence of 2n will be an AP. Therefore, sequence of 1 upon fn will be a HP. And we can see that it is 1, 1 by 2, 1 by 3, 1 by 4. If we take 1 by 2 common, it will be a harmonic series. So it will be a HP, and that's your option C. Now here the question is fx square into f 1 minus x upon 1 plus x. It is 64x. We need to find fx. Now this again is a cyclic substitution, because we know that if we replace x with 1 minus x upon 1 plus x in this expression itself, then it will be 1 minus x upon 1 plus x, and 1 plus 1 minus x upon 1 plus x. It will be simply x. So here we'll replace x with x minus 1 upon 1 plus x. So we'll get this as f 1 minus x upon 1 plus x whole square, and it'll be this fx, and this is 64 1 minus x upon 1 plus x. Now we'll substitute this value from this first equation. So we'll get this as 64x whole square upon fx to the power 4. It'll be this fx, and it'll be this 64 1 minus x upon 1 plus x. Now this is fx cube, so we can write fx cube will be this 64 into x square into 1 plus x upon 1 minus x. And if we take its cube root, we know that cube root of 64 is 4, and this is x to the power 2 by 3, and this is 1 plus x upon 1 minus x to the power 1 by 3, and that's your option A. Now the next one is domain of fx. Now there's no problem with x to the power 2 by 3, and we also don't have problem with cube root. Only problem is denominator should not be 0. So x, it should not be equal to 1. But we have derived this fx from this equation, and in this equation, the assumption is this should be valid for 1 minus x upon 1 plus x. So clearly x should also be not equal to minus 1. So domain of this function should be x belongs to r minus 1 and minus 1, and that should be your option D. And then the next question is we need to find the value of f 9 by 7. So f 9 by 7 is 4 9 by 7 to the power 2 by 3, and this is 1 plus 9 by 7. 16 upon minus 2, minus 8 to the power 1 by 3. So there'll be simply minus 8, 9 by 7 to the power 2 by 3. And that's your option C. So the correct options are A, D, and C. Now the questions, let f be a function defined on R to R satisfying f2 minus x equals f2 plus x and f20 minus x is equal to fx. Now basically this is symmetric about x equal to 2, and here also if we replace x with x plus 10, we can write f 10 minus x equals f 10 plus x. That means it is also symmetric about x equal to 10. Now we know that when a function is symmetric about two values, that is f a plus x equals f a minus x and f b minus x equals f b plus x, then it is a periodic function whose period is 2 times mod of b minus a. So this function fx will be a periodic function whose period is 2 times 10 minus 2. So it's a periodic function with period 16. The first question is, if f0 equals 5, then minimum possible number of values of x satisfying fx equals 5. Now we know that fx is symmetric about 2. So f0 will be same as f4, and both of them, they'll have the value 5. So in one period, there'll be 2 solutions. And in the interval from 0 to 170, you can take the value 0, 1 up to 10. So we'll have 11 solutions. And then we have solutions of the type 16k plus 4. And here again, k can take the value from 0 to 10. There'll also be 11 values. So total there'll be at least 22 values of f, which will take the value 5. So answer to this first question is this option D. Now about symmetry, we know that it is symmetric about x equal to 2. It is symmetric about x equal to 10. And it may or it may not be symmetrical about x equal to 8. Graph of y equals to fx is not symmetric about x equals 8. And for the third one, it says f2 is unequal to f6. Now fundamental period cannot be 1, because if it is 1, then fx plus 1 must be equal to fx. Then in that case, f2 will be f6. So fundamental period of fx is 1. This is certainly not true. Fundamental period of fx may be 1. Again, not true. What's clear is period of fx cannot be 1. So this is the correct option. Period of fx cannot be 1. Then in that case, f2 has to be equal to f6. And D is fundamental period of fx is 8. If fundamental period is 8, then fx equals fx plus 8. In that case, f minus 2, it is equal to f6, which could be true, but what we are certain is period of fx cannot be 1. Now the question is, we have defined a function from R to R such that f x square plus x plus 3 plus 2 times f x square minus 3x plus 5, it is 6x square minus 10x plus 17 for all x belongs to R, we need to find the value of f5. Now we can see 1 plus 1 plus 3 is 5, but here it will be 6 minus 3, 3. So it will become f3. So we get an equation in f5 and f3. And if we put 0, we'll get relation between 3 and 5. So it will become simultaneous equation in f3 and f5. So first we'll put x as 0. We can write f3 plus 2 times f5 will be equal to 17. And if we put x as 1, we can write f5 plus 2 times f3 will be 13. From here we can find the value of f5. So we'll multiply this first one with 2 and we'll subtract second from it. So we'll get 3f5 and there'll be 34 minus 13, which is 21. So value of f5 is simply 7. So answer to this first question is 7. Now we'll come to the second question. Fx is an odd function. That means f of minus x is minus fx, and we are given that f1 is 3 and fx plus 2 equals fx plus f2. We need to find the value of f3. If we put x as 1, we can write f3 as f1 plus f2. f1 is 3, so it will be this 3 plus f2. And if fx is odd, we know f0 is 0. If we put x as 0 here, we'll get f2 as f0 equals f2. No result. If we put x as minus 2, we can write f0 f minus 2 plus f2. Again, no result. Now we need to find f2, and what we have is f0, f1, and also f minus 1. What we'll do is, in this, we'll put x as minus 1, we'll get f1 equals f minus 1 plus f2. Now f1 is 3, f minus 1 is minus f1, so there'll be minus 3 plus f2. That means value of f2 is 6. So clearly f3 is 3 plus 6, 9. So answer to this second question is 9. Now it says fx is a continuous onto function satisfying fx plus f minus x equals to 0. That means fx is odd, and also we know f0 will be 0. And it says f minus 3 is 2 and f5 is 4 and minus 5 and plus 5. The minimum number of roots of this equation fx equals 0 is. Now since we know it is an odd function, we know f3 will be minus 2 and f minus 5 will be minus 4, and also f0 is 0. So f minus 5 into f minus 3 will be this minus 8 less than 0. Also f3 into f5, it is minus 8 less than 0. Then from Bolzano's theorem, we can say there is at least one root in minus 5 to minus 3 and at least one root in 3 and 5. And then we have another root, which is that x equal to 0. So this equation will have at least 3 roots. So the minimum number of roots is 3. Now the question is, a function f is continuous and has the property f of fx is 1 minus x Now we'll replace x with fx. We can write f of fx will be 1 minus fx, and we know that f of fx is simply 1 minus x. So we can write f1 minus x will be 1 minus fx, or fx plus f 1 minus x will be 1. And if we put x as 1 by 4, we can write f1 by 4 plus f3 by 4 will be equal to 1. So answer to this question is simply 1. Now the question is, a function fx satisfies this equation, which is 2f sin x plus f cos x, it is equal to x for all x belongs to R. Now we know that sine and cos, they displace by pi by 2. So if we put x as pi by 2 minus x, sine will change into cos and cos will change into sine. So we'll get a simultaneous equation. So we'll replace x with pi by 2 minus x. So we'll get 2f cos x plus f sin x, and it'll be pi by 2 minus x. Now we'll multiply this first equation with 2, and then we'll subtract the second. Then this f cos x will cancel. So we'll get 3f sin x. It will be 2x minus pi by 2 plus x. So there'll be 3x minus pi by 2, or simply f sin x is x minus pi by 6. Now if we take sin x as u, we can write fu is sin inverse u minus pi by 6, or the function fx is sin inverse x minus pi by 6. Now clearly, domain of this function will be from minus 1 to plus 1. So that's your option C. And we know that a range of sin inverse x, it is from minus pi by 2 to plus pi by 2. And if we subtract pi by 6, we'll get minus 2 pi by 3 less than equal to sin inverse x minus pi by 6, and it'll be pi by 3. So range of this function will be from minus 2 pi by 3 to pi by 3. So the correct options are B and C. Now the questions, let px be a quadratic polynomial with real coefficients such that 2 times 1 plus px, it is equal to px minus 1 plus px plus 1, and it says p0 is 8 and p2 is 32. So we'll assume, let px be ax square plus bx plus c, and since p0 is 8, that means c is 8. Now we'll replace it in this first equation. We can write 2 into 1 plus ax square plus bx plus 8 will be equal to ax minus 1 square bx minus 1 plus 8 plus ax plus 1 square plus bx plus 1 plus 8. So we'll get 2ax square plus 2bx plus 18, and it'll be equal to 2a x square plus 1 plus 2bx plus 16. Now we compare their constant part, we'll get value of a as 1. So px should be x square plus bx plus 8, and we are given p2 is 32. So p2 will be 4, 12, 2b plus 12 equals 32. Value of b is 10. So this polynomial px will be x square plus 10x plus 8. Now first question is sum of all coefficients of px. So sum of all coefficients will be 1 plus 10 plus 8, 19, and that's your option C. And second is a range of px. We have to find its minimum value m. Now p dash x will be 2x plus 10 equals 0, x equals minus 5. So its minima will occur at x equal to minus 5. So value of small m will be 25 minus 50 plus 8, and that'll be minus 17. So value of m is minus 17, and that's your option D. Now it says fx is defined as fx plus y equals fx into fy, and f1 is 2, then integral value of a, if we are given this summation k varies from 1 to n f a plus k, it is equal to 16 into 2 to the power of n minus 1. Now since we need only integral values of f, so we'll solve this question in integers. So let's take x and y as integers. We'll put x as n and y as 1. We can write fn plus 1 will be fn into f1, and f1 is 2, so it will be this 2fn. So fn plus 1 will be 2, and then for fn we can write this is 2 fn minus 1, and using iteration we can write 2 into 2 into 2 till f1, and f1 is 2, so it will be simply 2 to the power of n plus 1. So from here we can say this fn, it is 2 to the power n. And we know that equation of the type fx plus y equals fx plus fy. If fx is regular, are the forms fx equals a to the power x, and we are given that f1 is 2. So f1 is a. So value of a is 2. So from here also we can write fx is a to the power x. Now we'll solve this. It says this summation k varies from 1 to n f a plus k. So there'll be 2 to the power a plus k, which is nothing but a GP. And for this GP, first term is 2 to the power a plus 1, and common ratio is 2. Number of terms is n. So it will be this 2 to the power of a plus 1 into 2 to the power of n minus 1 upon 2 minus 1, and this is equal to 16 into 2 to the power of n minus 1. Now I'll cancel. So this is 2 to the power 4. That means value of a is simply 3, and that will be your option A. Now the question is, if p and q are positive integers and f is a function defined for positive numbers and attains only positive values such that f, and here it should be a product. So f x f y is equal to x to the power p, y to the power q, then p square is. Now what we'll do is we'll put y as 1, and suppose f1 is some constant c, then we can write f cx will be x to the power p, and if we take cx as u, we can write fu will be u upon c to the power p, or we can say this function fx, it is some constant x to the power p. Now we substitute it in this given equation. Then it'll be a x fy to the power p will be equal to x to the power p y to the power q, and this is ax and fy is a y to the power p whole to the power p, and will be xp into y to the power q. So we'll get a to the power p plus 1 x to the power p y to the power p square will be equal to x to the power p y to the power q. So clearly a should be 1 and p square should be equal to q. So p square is equal to q, and that's your option B. Now here the question is, fx is a polynomial with positive degree satisfying the relation fx into fy, it is equal to fx plus fy plus fxy minus 2, and we are given f4 equals 65. Then which of the following is or are correct? Now this equation is a disguised form of this other equation, fx into f1 upon x equals fx plus f1 by x. So what we'll do is, we'll first find the value of f1. So we'll put x and y both as 1. So we'll get f1 square and will be 2 times f1 plus f1 minus 2. So it'll become a quadratic in f1. So we'll get f1 minus 1, f1 minus 2 equals to 0. So either f1 is 1 or f1 is 2. If we take f1 as 1, then in that case, if we put y as 1, we'll get fx equals fx plus 1 plus fx minus 2. Then fx will become a constant function and it cannot take value f4 equals 65. So f1 is not equal to 1, f1 is equal to 2. Now in this given equation, we'll replace y with 1 by x to get it in its original form. So we'll write fx into f1 by x. It is fx plus f1 by x plus f1 minus 2, and f1 minus 2 is 0. So we'll get this equation fx into f1 by x will be equal to fx plus f1 by x. And we know that such equations have a polynomial solution as plus minus x to the power n plus 1. Now we need to find the value of n. So we are given f4 is 65. So we are given f4 is 65. We get it plus minus 4 to the power n plus 1. It is 65. Now it will be this plus sign. Then 4 to the power n equals 64, which is 4 cube. So value of n is 3. So we know it will be a plus sign and value of n is 3. So your function fx, it is x cube plus 1. And if fx is x cube plus 1, then f2, it is 8 plus 1, 9. That means option A is correct. Now 3 root 3 cube will be an irrational number. Option B is incorrect. F5 is 125 plus 1, 126. It's also correct. And then the roots of the equation, fx equals 2x square, are all real. So we'll check this fourth option, fx equals 2x square. So this equation, fx equals 2x square will be x cube minus 2x square plus 1 equals 0. So there'll be x cube minus x square and minus x square minus 1 equals to 0. So we can take x minus 1 common. We'll get x square minus x minus 1 equals 0. So the roots are 1. And then 1 plus minus under root 5 by 2. So all the three roots are real roots. That means this option D is also correct. So the correct options are A, C, and D. Now it says fx is an even function and gx is an odd function satisfying this relation. So if fx is even, we know that f of minus x is equal to fx and g of minus x equals minus gx, and we are given this relation x square fx minus 2f 1 by x, it is equal to gx. Now this equation we'll replace x with minus x. We'll write x square f minus x minus 2f 1 upon minus x, and this is g minus x. Now f minus x is fx, so it will be this x square fx minus 2f 1 by x, and this is equal to g minus x. Now both these left hand side, they are same. So from here we can write g minus x equals gx. So gx is both. It is an odd function and it's also an even function. So that means this can only be true when gx is 0. So gx is identically 0. So it's a constant function whose value is 0. So that means your option D is correct. So now we can write this equation as x square fx minus 2f 1 by x will be 0. And if we replace x with 1 upon x, we'll get 1 upon x square fx minus 2fx will be 0. And if we solve this, we'll get fx equals 0, where x is unequal to 0. B 2009 is going to be 0. And nothing is said about fx when the value of x is 0. So f0 could be anything. So it may not be a constant function and it may not be 0 for all x belongs to R. So the only options correct are B and D. Now here the question is, let f from R to R be a continuous function such that fx minus 2 fx by 2 plus fx by 4 equals x square. We need to find fx. Now we can write this as fx minus fx by 2 and then minus fx by 2 minus fx by 4, and this is equal to x square. And what we'll do is we'll let fx minus fx by 2 as gx. So we can write gx minus gx by 2 will be x square. Now we can use telescopic summation here. So we'll replace x with x by 2. We can write gx by 2 minus gx by 2 square will be x by 2 square. And in the end, we can write g x upon 2 to the power n minus g x upon 2 to the power of n plus 1 will be x upon 2 to the power n whole square. Now if we add them, then all these terms, they'll cancel out. And because we need gx, what we'll do is we'll take gx minus this limit n tends to infinite g x upon 2 to the power n plus 1. And then we'll have this infinite gp, which is 1 plus 1 by 2 square, 1 by 4 square to 1 upon 2 to the power 2n up to infinite. Now this is g0. So we can write this as gx minus g0 will be this x square, and this is an infinite gp, so it will be 1 minus 1 by 4, which is 4x square by 3. Now g0 is f0 minus f0, which is 0. So we'll get gx as 4x square by 3. Now gx is fx minus fx by 2. So gx is fx minus x by 2, and it will be 4 by 3 x square. Again, we'll use the same steps. So fx by 2 minus fx by 2 square will be 4 by 3 x by 2 square. I'll continue. We can write f x upon 2 to the power n minus f x upon 2 to the power n plus 1. It is 4 upon 3 x upon 2 to the power n whole square. Now again these terms, they'll cancel, and we'll take limit n tends to infinite to make this an infinite gp. So we'll get fx minus this limit n tends to infinite fx upon infinite. So it'll be this f0, and it'll be equal to 4 by 3 x square, and then 1 plus 1 by 4 plus 1 by 4 square up to infinite, which is an infinite gp, and it'll be 16x square by 9. So from here we'll get our function fx, and it'll be 16x square by 9 plus f0. So this is how we can find this function fx. Fx is given by 16 by 9 x square plus f0. Now we need to find f3. f3 will be 16 into 9 by 9, 16 plus f0, and that's your option D. And the next one is equation fx minus x minus f0. So fx minus x minus f0 will be 16x square by 9 minus x equals 0. So we'll get either x as 0 or x as 9 by 16. So this equation will have two solutions. And this is the answer to this question. Now the question is, if a periodic function fx satisfies the equation fx plus 1 plus fx minus 1 equals root 3 fx, and the period of this function is 4 lambda, we need to find lambda. Now there are two ways to solve this question. One way is to solve it rigorously, where we'll try and first eliminate this root 3 part, and then we'll somehow prove fx plus t equals fx. Now in this equation, what we'll do is we'll replace x with x plus 1. So we'll write fx plus 2 plus fx will be root 3 fx plus 1. And again, we'll replace x with x plus 1. So we'll get fx plus 3 plus fx plus 1 will be root 3 fx plus 2. Now here we'll put the value of fx plus 2 in this equation. So we can write fx plus 3 will be equal to root 3, and here will be this root 3 fx plus 1 minus fx minus fx plus 1. So it will be this fx plus 3, and this is 3fx plus 1 minus fx plus 1, which is 2fx plus 1 minus root 3 fx. Now it all makes sense because we have root 3 fx, which we can write fx plus 1 plus fx minus 1. So we can write fx plus 3 will be 2fx plus 1 and then minus fx plus 1 minus fx minus 1. So we'll get this as fx plus 3 will be equal to fx plus 1 minus fx minus 1. Now clearly we need fx, so we'll replace x with x plus 1. So it will be this fx plus 4. It is fx plus 2 minus fx. Now we'll try and cancel x plus 2 and x plus 4. So we can write fx plus 6. So here we'll replace x with x plus 2. It will be fx plus 4 minus fx plus 2. And if we add them, it'll cancel. This will also cancel. We'll get fx plus 6 equals minus fx. Now we have to make it plus fx. We'll replace x with x plus 6. We can write fx plus 12 will be equal to minus fx plus 6, and it's minus fx. So from here we can say fx plus 12 is equal to fx. So this function is periodic, and the period of this function is 12. So it says period is 4 lambda. So 4 lambda is equal to 12. That means value of lambda is 3. So answer to this question is value of lambda is 3. Now another way of solving this question can be by finding its characteristic root. So what we'll do is we'll write this functional equation fx plus 1 plus fx minus 1 equals root 3fx as an plus 1 plus an minus 1 root 3an for some fixed x. Now we can try this reoccurrence with the sequence an equals r to the power n. So it will be r to the power n plus 1 plus r to the power n minus 1, and this is root 3 r to the power n, or r square minus root 3r plus 1 equals 0, or r is root 3 plus minus iota by 2. So the characteristic roots are e to the power iota, pi by 6, plus or minus. So here this argument, it moves by pi by 6 per unit. So period of this function will be 2 pi divided by pi by 6, and which is 12. So again we can write 4 lambda equals 12, or value of lambda equals 3. So in this case, value of lambda is 3. Now here the question is, we are given a function fx, which is 1 by 2 fxy plus fx upon y for all xy belongs to R positive, and it is given that f1 is 0 and f dash 1 is 2. We need to answer some questions for which we need to find fx first. Now since x and y, they're both positive, so what we'll do is we let x as e to the power u and y as e to the power v. So we can write f e to the power u will be 1 by 2 f e to the power u plus v plus f e to the power u minus v. Now we'll assume a function gx, which is f e to the power x. So we can write this as gu will be 1 by 2 gu plus v plus g u minus v for all uv greater than 0. Now this is Jensen's midpoint equation. And because we are given f dash 1, fx is differentiable. That means gx will be continuous. So this gu, it must be a linear function. So this gu, it is a linear function. And if we look at this also, so suppose this is u and this is gu. So if we move up, we'll get gu plus v, and if we move down, gu minus v. Midpoint of these 2 points will always be the same point. That means these 3 points, they must lie on a straight line. So basically we'll get gu as sum au plus v, or f e to the power x will be ax plus b. Now we'll take x as log x. So we'll get this fx as a log x plus b. Now we'll find the value of a and b. We are given f1 is 0. So if f1 is 0, it means b is 0. So basically fx is a log x and f dash x will be a by x, and f dash 1 is 2. So f dash 1 will be a. So this a is 2. So our function fx is 2 log x. Now the first question is, we need to simplify fx minus fy, which is simply 2 log x minus 2 log y, and is 2 log x upon y, which is f x upon y, which was one of the options. And this second question is, we need to find the value of f dash 3. Now f dash x is 2 by x. So f dash 3 will be simply 2 by 3. And the third question was to find fe. So it is simply 2 log e, and it is 2. Now here the question is, we are given a polynomial such that f 1 minus x upon 1 plus x into f 1 plus x upon 1 minus x. This is equal to f 1 minus x upon 1 plus x plus f 1 plus x upon 1 minus x, where x, it cannot take the values 0 and plus minus 1. Now this is another form of this standard equation. So what we'll do is we'll let 1 minus x upon 1 plus x as u. So it'll be this fu into f 1 upon u, and it'll be this fu plus f 1 upon u, which is a standard equation. And we know that for this form, fu will be plus minus u to the power n plus 1. So your function fx, it is plus minus x to the power n plus 1. Now we're given f3 equals 28. So f3 will be Now, since it is positive, we'll have this plus sign. So it will be this 3 to the power n plus 1 equals 28. So value of n is 3. So your function fx will be x cube plus 1. Now it says we need to find the value of 1 upon 605. This summation n varies from 1 to 10 fn minus 1. Now fn minus 1 is simply n cube. So this is 1 upon 605 summation n cube, where n varies from 1 to 10. Now this is 1 upon 605. This is sum of cubes of first 10 natural numbers. So it will be 10 plus 1 by 2 whole square. Now this is 1 upon 605 into 100, 121 by 4. Now this is 5 times 20. 100 by 20 is simply 5. So value of this summation is 5, and that is the answer to this question.